Hello, my name is Chuck Dawson. I was the former training manager for York International's Controls Group from 1991 till 2006 when Johnson Controls acquired York International. I was responsible for the development of all training programs for the original ISN FACS 4500 and the ISN ConneXsys family of controllers. The new ISN tutorial covers the exact same content as the original 3-day Introduction to ISN Programming and Editing class that was conducted up until 2006, when Johnson Controls acquired York International. I originally started the ISN ConneXsys website to see how much interest there was for information on the discontinued York ISN ConneXsys control system. Just to give you some idea of the interest that there is for the ISN ConneXsys control system, take a look at this map. I have tracking on this website that includes a world map of all visitors to the ISN ConneXsys website, including yourself. This screen shows a copy of the map as of November 2014. As you can see, you are not the only one looking for training and support information. There are many ISN controls systems out there still in use today. I thought there might be a need for an inexpensive alternative to flying somewhere to attend a training class. That is, if you could, because there are none. So that is the reason I decided to develop a tutorial that would transfer the same information that would allow someone to gain the knowledge and skills they need to successfully work with the ISN control system. Let's take a look at the content of the tutorial. In the hardware chapter, Chapter 1, we start talking about the different models of the ISN ConneXsys control system. We discuss the physical setup and configuration of the input and output devices that you'll be connecting to the system. In the System Basics chapter, we explain how the ISN ConneXsys system is set up and how it works. Starting with a block diagram of the system, we will cover how the memory and the I/O status registers are organized and how they operate. Then we'll discuss how physical I/O devices are mapped into the controller. This is followed by an explanation of how the controller monitors input states and uses that information to control outputs. In the next chapter, we cover the ISN controller keypad display unit and its modes of operation. We cover how the keypad display is used for programming and editing purposes. In the next chapter, we cover the terminal mode procedures. We show how to connect the controller via the controller's RS-232 port with a computer running a terminal emulation software package, like HyperTerminal, which is included in Windows XP. In Chapter 6, we briefly go over using the York Icon Engineering software package. If you have this package, you can use it with all of the following lab exercises in this tutorial. Chapter 7 begins by discussing Feature 40, Digital Interlock, and how it monitors the status of digital inputs to control digital outputs. In this chapter, we also cover flowcharting methods, which are necessary before actually entering the control program into the controller. In this next section, we cover system configuration and setup. Field wiring checks and power-up procedures are covered. Feature 50, System Diagnostics, is explained. Feature 45, Channel Configuration, is where we set up the communication parameters for the COM ports, like baud rate, start bits, stop bits, and parity. And next we move on to coordinated lab exercises. After that, Feature 10, System Calendar, is covered, where we set up the real-time date clock parameters. Next, Feature 6, Binary Value, is where we set up our digital output statuses. Feature 63 is Input Card Configuration, where we map in the input devices wired to the system. Feature 64, Output Card Configuration, is where we map in the addresses of the physical output devices that are connected to the system. Feature 60, System Structure, is where you set the operational mode of the controller, run, halt, or monitor. And then we move on to reinforcing lab exercises. This next section begins with the setup and configuration of Feature 2, Analog Inputs. This is where we do the scaling for different sensor types wired into the system that provide values like temperature, pressure, humidity, etc. We then discuss feature 39, analog interlock, where we use the status of these analog inputs to control digital outputs. Then we move on to feature 3, a discussion of system variables. This particular feature is used to perform calculations and other math functions that are used in the control program. Feature 13 is sensor input. This is where we can set up a lookup table typically used for thermistor tables. In this chapter, we discuss feature 11, analog alarms, and feature 12, digital alarms. Following this, we have coordinated lab exercises. This section covers historical data features. Feature 14, hours run, can keep track of the number of hours a piece of equipment has been operating, assign alarm limits to it, to alert that periodic maintenance is required. Feature 15, analog history, can keep a record of change in value over a period of time, such as temperature, pressure, humidity. Feature 16, digital history, can provide a record of a change of state of a digital point. And then feature 21 and 22 is a special feature called event configuration. In the next section, we talk about the scheduling features. Feature 10, system calendar, where we set up a number of time-date references that are used in our feature 31 time programs and our feature 33 time schedules. In this next section, we cover the network features. We explain the ISN ConneXsys system architecture, how the CX router is set up and configured. We go over the MSTP, master-slave token passing, local area networks of ISN controllers, how they're set up and how they're configured. We move on to feature 45, channel configuration for BACnet, to prepare for actually sharing data over the BACnet network. Then we move on to feature 28, analog transfer, where we prepare to transfer a value, possibly a temperature or pressure, over the BACnet network to be shared with other BACnet compatible devices. Then we set up the BACnet device instance, which is a parameter required to do the BACnet transfers. We cover then the York BACnet object types. What type of data in our controller can we share with other BACnet compatible devices? Feature 20, network objects, is covered, and then we have an analog and digital transfer lab. Included in this tutorial are PDF copies of the documentation that will help you understand the ISN controller's instruction set and the specific hardware manuals for the IDC, UDC, FDC, and VAV controllers. The end goal is to gain the knowledge and tools that you need. This tutorial will provide you with that knowledge and the tools that you need to successfully begin working with the ISN control system. You will gain the knowledge and skills that you need to program, edit, and maintain the ISN ConneXsys control system. Thank you for your attention.